Basically, Java champions are like voted by the community. Like, so a Java champion nominates another Java champion, and then there's a voting process with which you are, selected as a Java champion. And there are about 315 in the entire world, and I'm one of them. And there are like many more around at GIDS. So it's one of the places where you get a lot of Java champions around. So you can feel free to stop any one of them and ask questions, or you can stop me as well. Next is I'm a project leader of Eclipse Collections. Eclipse Collections has nothing to do with the Eclipse IDE, but it's rather a collections framework. It's an open source collections framework. It has been developed since 2004, and it was moved to the Eclipse Foundation in 2015 and rebranded as Eclipse Collections. Okay. Lastly, I am a software developer at Goldman Sachs. Like the last one is mechanical engineer, but the last time I worked with a hammer and a chisel was in 2010. And in 2012, I started working at Goldman, and I've been writing software for a living. And it's been an amazing journey. So the way it's going to go about, the way we are going to go about this is we have JVM languages. Like, it's going to be Java, obviously, because that's the base of everything. Then we are going to look at Apache Groovy, Kotlin, and Scala. Okay, so we are going to be primarily comparing 4 languages. I'll take you through what exactly the domain is and what we are going to do to essentially compare them. We are going to be comparing a few nuances of each language, and I want to keep this like a fairly open-ended talk, and feel free to interrupt me in between. Like, there's a light shining here, so in case I don't grab your attention, just holler out my name, Nikhil, or just make like wide gestures so that I can actually look at you. Okay, so going back to the talk, basically the base of this is going to be a JVM language, right? That's why we are going to use Java, like I said, obviously, for the comparison purpose. That's going to be number 1. Then, secondly, even though we are comparing 4 languages, there are other languages as well. There are some passionate people about Clojure. Okay, Clojure is a really cool language in my opinion, but at the same time, like in the interest of time, we just chose these 4 because these 4 seem to be the most trending currently. Okay, so that's one of the reasons. Then going to Apache Groovy, we will actually go about it in a second. And then JRuby and Jython. So JRuby is actually one of the founders of JRuby is Charles Nutter. He's a good friend of mine, very cool guy. But we are not going to look at that. But you will be looking at that for Ruby on Rails and all other stuff. Okay. So the very first one, apart from Java, I mean, how many of you know what is Java, first of all? Because I don't have a slide about Java because I assume that people will know. Anyways, Java is basically it's the Java ecosystem. It's a programming language which used to be owned by Sun Microsystems. Then Oracle took over Sun Microsystems, and then as of last year, now Java has become open source, partly as a part of OpenJDK, as well as there is some licensing around it, like where there is more than one JVM provider or the JDK provider which is there. So there's Azul, there's Red Hat, then there's OpenJDK, as well as there's Oracle. So, but again, for all the other languages to run, you need the Java virtual machine. Now, the Java virtual machine has nothing to do with the actual JDK. Okay. So that's a little bit of a distinction. So the first one is Kotlin. How many of you know about IntelliJ IDEA? Pretty much 90% of the audience. So essentially, and I'm going to be using IntelliJ IDEA to actually type out the code and explain the differences. Kotlin was actually written by the company which owns IntelliJ IDEA, JetBrains, and it has a full, it has pretty cool, tricks, and it is a really, really functional type of language. The basic, functionalities are the coroutines and the strict null checks, which according to me are amazing, as well as aggressive type inference. The type inference helps you write a lot of succinct as well as safe code. Next one is Apache Groovy. How many of you have written builds in Gradle? Gradle builds. Okay, most of us. How many of you are Maven users? Okay, some of you. So the build in the project which I'm going to code is actually Gradle. And the reason why I used Gradle was because that was the easiest to get it going for all the 4 languages to coexist at the exact same time. Like I had to write a build which will work across, like in the exact same project, it had 4 different modules with 4 different languages. And Gradle was the one which helped me do that quickest. Like, and again, I'm not a purist who will say that, oh, I'm only going to use Maven, or I'm only going to use Ant, or I'm only going to use Gradle. It's whichever technology works, right? So I was using Gradle, and Gradle is basically, you know, it's written, like the builds are written using Groovy. Okay, it was created in 2007, and it got moved to the Apache Foundation in 2015. After V2, like since 2012, it's compiled statically, and you will see when I'm writing the code, that's like, you know, it's one of the most interesting things about like a statically compiled language, because you don't know whether something is working fine or not, but at the same time, sometimes you know something is working fine or not. So it's like, you know, like it's borderline about that. Okay. Then next one is Scala. So it was created in 2001. It's one of the stable, and like the Scala group is extremely passionate about the functional nature of it. Okay. And I will not lie, it's one of the most difficult languages to learn, but once you know it, like you will just love it. You will stop, in my opinion, like you will just feel enabled to do stuff. And as I'm writing code, you will see why. Okay, I'm not an expert in Scala. I just know Scala to like probably barely survive. Okay, and when I say barely survive, as in I'll have to Google how to write hello world as well in Scala. So like I just know how Scala works in general. Then the best part about Scala, in my opinion, is actually again, since its inception, since day 1 of Scala, it was built around making it, you know, for functional programming. And so it just becomes like really beautiful to write. Okay, a few interesting things about Scala is like Scala comes with its own compiler, and you need to basically, if you're using IntelliJ IDEA, then it comes with the Scala plugin, so you have to do very less wiring, which is there. But if you're trying to run it through a shell or something, then you need your own, you know, SPT. Okay. So going forward, like I'm going to quickly explain the domain, and then after that, I'm going to open my IDE and start coding. Okay. So how many of you have played cards, like, or still play cards? I mean, for fun, right? Like, so it's one of those things, right? Like a deck of cards should be the most easiest domain to understand. So that's why we took. And again, I'm not the sole author of this talk. Like this talk was co-created by 3 of us. It's Donald Raab, who is the creator of Eclipse Collections. Leo Lima, he is also a Java champion and a part of the JCP Executive Committee, and myself. So when we were coming up with this talk, we had to figure out a domain which everybody would understand. Like I wanted to spend like the least amount of time in explaining a domain. So a deck of cards is something which I can explain like universally. There are 52 cards, right? 13 ranks, 4 suits, easy. And then what should happen with a card? You should be able to create a deck of cards. Then you should be able to shuffle the deck of cards, and you should be able to deal the deck of cards, right? And you should be able to do this across all languages, right? How hard can it be? Right? Fairly easy, right? What do you say? Yeah, fairly easy, right? Okay, fine. Then let's write the code and see how easy it is. Okay, I'm going to spend a little bit more time on the JDK implementation, just so that we understand what we are trying to do. Okay, and is the font visible for the people at the back? Okay, or you want me to increase it more? Yeah. How about that? Good or more? You have to tell me. More? Yeah. Okay, that good? Yes, no? Okay, good. I'm going to take a yes. All right. How about that? Okay, good. Yeah. Now I could see like many heads like nodding, so I'm like, okay, fine. Now that's good. Like previously, it was very tentative. You know, so this session is for all of you. Okay, like it's not for me. So you should like be enabled to just interject in between and ask me questions. Okay. So the very first thing is we are going to we have the card class. Okay, and the card class implements comparable. Okay. Right now, there are compile errors. We'll fix that like in a minute. But essentially, a card is comprised of a rank, right? And it is comprised of a suit, right? And we'll create our good old constructor as well as some getters and setters. Okay? So this is fairly straightforward. A card has a rank. It has a suit. The way you construct it is, you pass the rank and the suit, and you get a card, right? When you want to do a getter, when you want to get a particular rank, you have the getters, and there's no setters because this is final, okay? This is very important that this is a final variable, okay? Now, the other interesting aspect of this is you can see that there is a compiler error because we are implementing comparable, but we have not implemented compare to, right? We'll do that in a second. But along with that, like people will ask, why do you need a card to be comparable? Okay, well, in this domain we really don't need it. But the reason why we added it is because the compare to methods across all the languages are significantly different. So it's like one of those things which we can use to compare. Okay, so let me quickly actually add other. So if you see, this is my compare to method. I'm using IntelliJ Live templates. So that's where I basically type some keywords and most of the code gets generated. It's like a boon for live coding. I can spend more time in explaining stuff than typing boilerplate code. So let's look at this implementation of compare to. Okay, this is the Java 8 syntax where you have comparator.comparing. And what comparing lets you do is it lets you chain the comparators. So basically, the very first thing it's going to do is it's going to end up comparing the suit. If there is a tie, it's going to compare the rank. Okay? And if there is a tie on the rank as well, then it's equal, basically. Okay? So that's what it is doing. And this is called as like chaining the comparators. And if you see, I have not written any self code. Like this came with the JDK itself. Okay? So this came with the JDK, like there's nothing like that I have done in this. Okay, then secondly is like a few helper methods for the equality where you want to check whether something is a diamond, something is heart, something is spade, etc., etc. And since it's an enum, you can just do equal to. Now this is very important. The way this talk progresses is like I'm going to implement the whole deck of cards for Java, then do it for Cortland, then do it for Groovy, and then do it for Scala. Okay, so there are these nuances which I'm highlighting. You will end up seeing across all of these languages how they differ. Okay, so there's this equality there. And now, lastly, what I want to show is the actual equals method, where you actually have like a nice waterfall if else logic going there. Okay, now and the toString is basically you're just saying something of something. The next aspect is we already now have a constructor of card, right? But essentially, when you want to create a deck of cards, what you need to do is you need to get all the 13 ranks and all the 4 suits, and you need to do a Cartesian product of it. Correct? Fairly simple, right? So let's see how we'll do it in Java, if I can find my cursor. All right. So all right. So the Cartesian, the weird part is the resolution on my screen is completely different, and here it's completely different. I don't know why. So most of the times, like, I'm like, okay, which part of the screen am I? But anyways, going back here. So basically, what the Cartesian product does is you need to take each one, it's a nested for loop at the end of the day, okay? Now, the interesting thing is if you see the sets.Cartesian product, this is an API coming from Eclipse Collections, okay? And since being a project lead of Eclipse Collections, it's a Java collections framework, so why won't I use it, right? If it ends up helping me write succinct code. But essentially what it does is it takes two sets, does a Cartesian product, as in like, an inner loop, finds like a nice flattened out, collection. It returns a lazy iterable, okay? A lazy iterable is, it's an Eclipse Collections iterable, okay? It's similar to your stream, but it's reusable, okay? Like the way your streams are lazy, okay? Until unless you have a terminating operation on them, they won't be evaluated. It's exactly the same thing for lazy iterable, okay? But some people will say, hey, I don't want to see the Eclipse Collections example. I want to see plain old Java. Fine, I have it for all of you. It's right here. Okay, it's right here. It's the stream of cards, okay? Basically, this is the Cartesian product implementation of it, where all you're doing is you're taking the stream on set 1, doing a flat map, and then you're doing a card of each and every entity, okay? And if you see, it actually returns a stream here, okay? So that is also lazy. The difference, another difference between the lazy iterable and stream is that you can reuse lazy iterable. Stream you can only use once, and after that you'll get a stream exhausted exception, okay? Is everybody with me right now? Okay? All right, so how many of you know what is a flat map? Okay, just one. So let me explain it for the others. So have you seen the movie Inception? Yes? How many? Okay, most of you. All right. How many of you understood it in the first go? Yes, thank you. All right, neither did I. I had to watch it twice to actually understand the movie completely. All right, so if you see in the movie Inception, it's basically a dream inside a dream inside a dream inside a dream, right? There are like 3 or 4 dreams which are there. So flat map, the way I understand it, is like an inception pattern, okay? Basically, you have a dream outside here, okay? That dream comes and collapses on the other dream. Okay, if you flat map it again, it will collapse it on another dream, it will collapse it on another dream to get you like one flattened, dream, like so basically one movie, okay? So essentially what this is doing is, this inner lambda returns, returns another, returns more than one element. It returns an iterable or a stream, okay? What the flat map does is it flattens it. So if it has like a set, if it has a set of sets, it will return just one set, okay? Does that make sense? That is flat map for you, okay? It's basically flattening it. It's, I don't know how else to put it, but it's essentially flattening it. It's similar to if you were to do like a group by in SQL and then just output it out like as all the rows as just one, all the rows as just one columns, flatten it, and basically denormalize it, okay? That's what it's doing. Any questions on this so far? Okay, sorry? Say that again? Uh-huh. Mm-hmm. This is a set. No, this is a set. No, the flat map is the name of the method. It's an API. The way flat map works rather, it's nothing but flattening it. So map, okay, taking a step back. What a map is, this in Java, map set2.stream.map, it doesn't create a map. A map is basically it transforms, okay? It takes you from one object to another object. So let's say you had a string and you wanted to convert it to an integer, you're mapping it, you're transforming, okay? So in Eclipse Collections, it's called as collect, okay? But in the JDK, it's called as a map or transform. So flat map is a special type of map, Okay, this has nothing to do with your hash map or a linked map. Okay, is there any other question? I'm happy to like discuss this. Like it's one of my favorite topics, collections. All right, so from here, what we're going to do all over is we use this implementation mainly because of two reasons. One is it comes from Eclipse collections, and I'm the project lead, so I want to dog food my own framework. The second one is it's more succinct, okay, and it's more understandable. Also, the lazy iterable allows me to reuse it, so I have to write less code. Okay. From there on, I will go, and here's the weird part. Like I have to always go on deleting the methods which I've written, but trust me, I will take you through those exact same methods again. The reason I have to delete them is because otherwise it won't, compile, and I can't run the tests. Yes. Yeah.
What does that mean?
Okay. So you know how stream. Let me actually show it in example. Let me finish this this part of the code. Then I'll show you what I mean by it's reusable. Okay. We'll digress a little bit, but it's okay. So now that we have created a deck of cards, or like basically cards and multiple, not just one card, but multiple cards, we want to shuffle it, right? The way you shuffle in Java is you just call shuffle this, right? And in order for repeatability, what we are doing is we are shuffling it 3 times, okay? That's why you will see shuffle this written 3 times, okay? Now, take a note of this, because this is going to change for other languages, okay? Another thing is we are using toStack here, which ends up returning an Eclipse collections mutable stack, okay? Now, people will ask, why are you using an Eclipse collections mutable stack? Is it because it comes from your framework? Not exactly that reason. The reason is the stack in Eclipse collections actually works as a proper stack, okay? How should a stack be? The last in should be the first out, right? Whereas in Java, the stack extends vector, so it's actually FIFO, okay? First in, first out. So basically it behaves like a queue, right? That's why they say that you should use a deck when you want a stack-like behavior. But in Eclipse collections, we just have a stack which behaves like a stack and gives us that API. That's why we are using the stack. Now, because we are using the Eclipse collection stack, the deal method in Java becomes very easy. All you have to do is pop the number of cards that you want to deal, right? And put them in a set and give it out, okay? Fairly straightforward, right? Now, we have implemented pretty much the main aspects of the domain. We have created a card, we have created a deck of cards, and the way we create a deck of cards is basically, we just end up putting them in a list, okay? Then we have shuffled the card 3 times, okay? And then we can deal the card now, okay? So my domain is set, right? It should work, right? Do you think it'll work? How do you know? You just hope it works? You know it works, or you just trust me that it works? You hope it works. Trust me, hope is never a good strategy, okay? Hope is never a strategy. If you ever work in my team, okay, and I'm hiring like in Bangalore as well as in Salt Lake City. I'm based out of Salt Lake City, and I like the mountains, so I'm originally from Pune, where there are mountains. Went to Salt Lake City, where there are mountains. I have a team in Bangalore as well. I'm hiring for that. I'm there as well. So if you ever work for my team, you'll know that like I trust people, but I love to verify. And until and unless you show me the tests, I will never pass your code review. So let us actually run all the tests. And you will see for Java, the tests are like fairly interesting, because we had to like, how can you test something, which you have created, right? Is a test, like it's expected against, observed, right? But if you're the one who is writing the expected, and if you're the one who is writing the observed, how have you not, messed up the test? So what we did was we actually create the expected in one way and the observed in another way, and we made sure that our implementations yielded the exact same result, okay? So we have all of these tests. And now I'll answer that gentleman's question about what does it mean it's reusable, okay? Unless anyone else has any questions in between. Any, okay. Test public void reusable stream, okay? So now let's say I am going to create an array list, okay? And I will end up populating an array, populating the same array list from, hang on, okay, dot for each, and I'm just going to say array list add, okay? So oh, that's why. Okay, so basically I'm adding it to the array list, and let us quickly, you know, output this just so that you know that it is populated 0 to 5. Okay, fair enough. Now what we are going to do is we'll end up doing array list dot stream, and to answer to the other gentleman what map is, what I'm going to do is I'm going to just say map and then each string dot value of each, okay? So things don't end here. You have to always collect it to a list, right? So dot collect and collectors dot to list, and I'll end up storing this as a variable, okay? And then if I do an s out on collect, it should again print 0, 1, 2, 3, 4, 0 to 5, but these are strings, okay? Fair enough? With me so far? And let me quickly indent this. So or rather, I'll just do string plus here, okay? Let it rerun so that you can see this is a real string, okay? That's why I did that. Now, again, it's mapping as in it's transforming, okay? Now the interesting thing over here is the person who wanted to know what is reusable is, if I were to get this out as a variable, just call it a stream, right? It is there, right? Now, I should be able to basically say stream dot collect, right? And each the string dot value of each. Okay, I'm doing the exact same thing that I was doing before, and then dot collect. Oh, sorry, not collect. Map. Yeah. Dot collect collectors dot to list, and then I'm just going to do an s out here. Oh, sorry. Okay, collect one, another different one. Now if I run this code, you would see it ended up printing the first part, right? The first map. The second map, it says it's an illegal state exception. The stream has already been operated upon or closed, right? So you can only use that stream once. Now this was the way I got the stream was fairly straightforward. I just had an array list. But let's say you have like a big program where you are actually deriving that part of the stream, and you need to have two different operations be performed, right? How do you do that? You'll have to get that stream again. You'll have to get another copy of that stream. Does that make sense, right? So here, now that's what I mean by reusable. Now let's say I was to use, so for the same array list, which is there, right? If I were to say lazy adapter lazy iterate dot adapt, if I'm supposed to do the adapt here, okay, and I end up taking that lazy iterable out, and I'll do the exact same operations that I did before, but now I'm just going to do them in line. Okay, so I'm going to do adapt dot collect, because in Eclipse collection it's called collect. Okay, and then I'm going to do each string dot value of each. Okay, and then I'll do this to list, because on Eclipse collections you get the API directly on the iterable itself, and I can do an s out here. Okay, and now I'll do the exact same thing again. Previously I had here string plus, right, and I have that. Okay, I did the exact same copy. You can see it, right? You can see both of them. I do need to comment out this part, otherwise it will throw an exception. And now let's rerun this. Okay, so if you see this 0 1 2 3 4 0, so it reused the same lazy iterable.
How are you doing that? Are you taking the copy out of it?
We'll take that offline. Right. The code is open source, by the way, on GitHub. So I can quickly tell you. So if you go to eclipse.org/collections, that's our website, and you can go to GitHub. Okay. Okay. Any other questions on this? I'll speed up the next part. Okay. All right. Let's go to Kotlin now. The beauty of Kotlin is I pretty much don't need any code. I mean, that's like no code. Let me quickly get back the Kotlin card. Okay. So the beauty of Kotlin is I don't need much code. Okay. Why do I say that? Now, interesting thing here. They have something called as a data class. Okay. And data classes are going to come to the JDK in the eventual future, which is there. But essentially, a data class is nothing but like your Java POJOs, where all you're trying to do is just maintain a state. Okay? This class, the card class, is just responsible for storing your rank and your suit. Okay? It has no other operations to do. So, since it doesn't have any operations to do, all it is doing is just holding the data. And since all it is doing is holding the data, is what Kotlin says is, all right, fine, I'll take care of your constructors. I'll take care of your getters and setters. Okay? And I will take care of your string as well. I will take care of your comparators as well. However, you can override it. Now, a few nuances here. You can see this is val, okay? VAL in Kotlin. That stands for private final, okay? Again, it's succinct. But if you change from VAL to VAR, okay, the VAR stands for just private, okay? It's not final, okay? So a small nuances out there. All right, I'm going to go back to VAL here. Another thing is the equal methods. If you see, now the function, you don't need that, curly braces, open, close, and everything. You can just inline the functions. The equals, which in Java was just enum equals, okay? Whereas in Kotlin, this is actually an overloaded operator for equals, okay? So that's one nuance. And lastly, if you look at the toString method, okay, this is called as templatizing. The $rank and $suit, it's called templatizing, which Kotlin lets you do. It's pretty cool, in my opinion, right? When you have a $sign. All right, now, if you look at this, so in Kotlin, when you want to create a public static method, okay, and this is how I understood it, because again, I'm a mechanical engineer, so like some things don't come naturally to me, whereas others do. This was one of those where I had to draw parallels with Java, okay? So in Java, the way you have public static methods, in Kotlin, you have companion objects, okay? Basically, what it is saying is, I'm going to expose a public static method called as getCards on card, okay? Function is like a method, okay? Now, here's the interesting thing. Rank is an enum which has a method values, similar to enum set.values, right, that Java has. However, you will see on that array itself, you have the Flatmap method, okay? You don't need any of the other syntactic sugar where like, you know, you need to expose another method and then, you know, call that, like generalize it and everything, okay? So this is fairly interesting that like you can just have a flat map here and you can have a map here. Again, these names, where is he? These names are borrowed from the JDK, where JDK also has flat map and map, okay? And now it is fairly straightforward. This it is an automatic, you know, it's an inferred variable similar to Scala, where it's basically whatever came in here, that is called as the it, okay? It took me like 2 seconds to understand where is it coming from. So, all right, any questions in this implementation? Okay, there's one nuance about comparators. Like I'm pointing out the nuances in these languages here. There's one nuance of this comparator. This is a symbiotic relationship between JDK and Kotlin, okay? Here if you see, the comparator.comparing is actually coming from the JDK itself. Look here, comparator.java, okay? However, all the next methods, the then by and the compare, are coming from, the then by is coming from Cortland, and then the compare goes and comes from the JDK, okay? So this is where you can actually use like the tips and tricks that you knew from your Java days, even for Kotlin, okay? So you can get the best of both worlds. Any questions on this? Yeah, pretty much, yeah. So this talk mainly does not show anything about performance, because when you're doing comparison of, so again, I don't expect to have Java in like a very low latency solution. That's where you'll use C++, okay? Scala is very good at functional programming, so that's where you'll use Scala. Even though Java is going closer and closer to Scala, or like is making strides in functional programming, again, the whole point is you use the best tool for the job which is required. And that would mean that if you have to do your performance testing to figure out which language works better, you have to do that, okay? But that said, yes, there may be some overhead involved. I have not done any benchmarking on that. I won't generalize it that way, because it depends. Like for example, IntelliJ, it's written in Kotlin. It performs fairly well for me, right? So again, it's you cannot generalize it like that. Each one comes with its own flavors, you know. It's like the way I'll give an example. I love food, and if anyone has seen my tweets this morning, like, oh my God, I had like the best breakfast in the last 6 months. But basically, it's like, you know, you have idli, you have dosa, you have uttama, you also have vada pav, right? It depends on what you're hungry for that day. Okay, each of these languages. All right, the next one is shuffling. Let me quickly speed up, because otherwise we'll run out of time for the other two languages. Okay, shuffle Kotlin. So if you see here, Kotlin decided that they don't want to own the implementation of the stack, okay? So they said, we'll just rely on the JDK stack. And then we were like, okay, but JDK stack doesn't behave like an actual stack, so we'll go back to Eclipse Collections as stack, okay? So even in this implementation, your output is an Eclipse Collection stack, okay? This changes in other languages, I promise, but this was like fairly cool. Now, the other thing about this method of stack is like, if you see the int range 1, 3, that's an API which Kotlin has given, okay? You go 1, 3, and for each, you're going to call the card copy.shuffle on that random, okay? Now, the interesting thing over here is the two mutable list, which is this, that comes from Kotlin, okay? And on this list, which is there, you have the shuffle method already available, okay? That's the reason why you can just do for each, because then the same the same copy is shuffled 3 times. Okay, so a copy is shuffled, the output is shuffled again, it's shuffled again, and then it is outputted at the end. Okay, does that make sense? And the stacks.mutable with all, it's an Eclipse collections factory which will return the stack to you. Okay, and now when you have to deal, it becomes a little bit more interesting than the JDK. You just can't pop and do toSet, because in Kotlin, you're actually returning Kotlin's mutable set. Okay, does that make sense? I'm not returning Eclipse collections' mutable set. It's fairly, confusing it's confusing to me sometimes, where like I don't know which set am I using. Is it the JDK set, or is it the Eclipse collection set, or like what exactly is going on? But this is the Kotlin set, and here they have not actually exposed a factory method which will take another collection to output out the set. That's why we go similar to the hash set factory way, hash set way, where you initialize the hash set, then you add all and you return that. Okay, make sense so far? Do you think this will work? Well, you got to test, right? So at the start of this month, I gave a talk in Moscow. It was JPoint, and that was a completely test-driven development talk where I did not have a project at all, and I started implementing different collections. But what I did have was all the tests which were there. And like each of the compile errors, I went on fixing, and that was another fun talk. Here, at least I have tests and I have implementations. Otherwise, nothing will run. Okay. So, all right, this runs. We can go up ahead with Groovy. Now, the interesting thing about Groovy is it's really, really close to the JDK, and that's very apparent when you end up doing this implementation. Okay, it literally has the exact same constructs. It literally has the exact same curly brackets. The only thing that it doesn't have is like the keyword private. Okay, it even has a similar constructor. But can you see one difference, one very, very big difference? Yes, you need semicolons. Can you see another very, very, very big difference? Look at how the comparable is implemented. There's no comparator here, okay? By just this annotation, sortable, and you give it an array of the members that you want to compare against, okay? The comparator, the compare to method, is inherently created for you, okay? There's no comparator that I have written, all right? And moving on, Groovy card methods. If you see, now instead of Flatmap, they call it collect many, okay? Instead of map, they call it collect, okay? But at the end of the day, it's the exact same nested loop, okay? Again, it's like whether it's idli, medu vada, or dosa, right? It is the exact same batter, right? It depends on what you're in the mood for today. All right. Now let's look at the shuffle. The shuffle in Kotlin, the shuffle in Groovy, sorry, is a little bit interesting than all others. Okay. Because one of the things is the collections.shuffle that I have to use. That's the JDK collections. Okay. Like the collections is the utility that comes from JDK, because Groovy does not have a shuffle utility. Okay, as one. Second is, if you look at the array list, this array list is actually Java util, JDK's array list. Okay, because Groovy does not have its own array list. Okay, now, however, it does have its own list. Okay, does that make sense? So, going back, this card copy which is there, okay, this deck which is there, that's a list, okay? Now, the list, Groovy has that list as well, okay? When you do a 3 dot times, now it's similar to int range, but the 3 dot times is much more terse, you end up getting the shuffled card copy, right? We had to do a card copy dot reverse because Groovy's list has a method called as pop. Okay, so if I'm to do deal Groovy, then you will see that all I'm doing is on the deck I'm just calling pop. Okay, for the number of times which, you know, one to count, pop, 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 and put it in a set. Okay, but now when you're doing a pop, what should happen? The last one should be popped out, right? That was true. However, the method changed from 2.5, where the pop actually was the first one out. Okay, so it was like, you know, instead of it being the last it being LIFO, it became FIFO. Okay, now at one of my previous talks, someone asked, but why did you have to reverse it? Okay, one reason was because it shows up a nuance of Groovy that not many people would know. The second thing is our tests were failing. If I remove that reverse, the entire order changes, and our tests, because you have to have the expected versus the actual, right? Groovy was exactly the opposite. That's how we found it. Okay, that's one nuance. Okay, and again, this the two dot operator which is there, that's another way of saying two. Okay, so one to count, and do that those many times. All right, so let's look at deck of cards Groovy and make sure that the tests run. And I can remove the reverse and show you the test fail. It actually took a while to figure out because it's 52 cards, right? Like I can't go through 52 elements to actually figure out why exactly the first one is coming out. Okay, so this is working fine. Now, let's go to Scala. All right. Who among here is a Scala developer? Okay, just two. Who amongst you here have known of Scala or like tried a little bit of Scala? A few of you. I will not lie. Make sure you at least know a little bit basics of Scala because it's a very interesting language. Okay, it's one of those languages where, you know, once you get it, you will get it. If you don't get it, you won't get it. Okay, like, but it is an extremely interesting language, and it's something which, like, at least we should be aware of. Okay, so please do take that, like, at least do like a basic course or something. Spend a couple of hours on it. Okay, now let's implement Scala card. Okay, Scala card. Now, similar to what Kotlin has in data classes, Scala has case classes. Okay, Scala was before Kotlin, so I don't know if Kotlin borrowed the idea from Scala and Java borrowed the idea from Scala or from Kotlin or how it worked. But whatever is the data class in Kotlin is the case class in Scala, or whatever is the case class in Scala is the data class in Kotlin. Okay, whichever way you want to look at it. Now the interesting thing here is instead of you saying implements comparable, you extends ordered. Okay, you end up extending ordered. And now this is where you will see the functional nature of Scala, right? You don't need an equal equals, but you just call it EQ, and it's a synthetic function. And now when you look at the compare, it's again one line, okay? Because what ends up happening is Scala automatically creates this as a tuple. Okay, it creates I think they go to like 12. I'm not too sure. I'm not an expert, but basically they say, all right, this is a tuple, and this is another tuple. You just compare it, okay, and you can go on chaining it like that. Okay, so that reduces a lot of developer headache, and this is just basically you're typing what you need. Okay, the toString is similar to all the other ones. It's just the basic, you know, the way you define the function. Now lastly, the interesting part of Scala is the Scala where you end up putting your private static methods. Okay, if you see, this is actually outside that class declaration. Okay, this curly brace which is there, that ends here, which is where your case class ends, right? But this is outside, right? And now this is fairly interesting for like a Java developer where you're saying, oh, but after the last curly brace you have more code. What is going on? right? Something bad must be happening. No. That's how you write Scala code. Basically, you're saying is you're defining a function get cards on the object card, okay? So that's why like it might be that your entire class ends there, but there's more code after that, okay? And again, it's similar to the previous one of Flatmap, right? This is something which a person like me who is like a Scala illiterate will understand, okay? There are some Scala experts who have been in Scala like forever, or like who understand Scala. They will write it in a comprehension style, okay, where the arrows actually flip. Can you see that? And this is actually their nested for loop, where it says nest your for loops and yield a card, okay, by passing the output of each for loop. It's pretty cool once you get it. I didn't write that code, by the way. Someone raised a pull request on GitHub repo, and I just merged it. But I find it like extremely cool. Okay. And now, lastly, the shuffle and the deal. Okay. So let's look at shuffle first. Shuffle Scala. Here, what you do is similar to the JDK where you do shuffle this, shuffle this, shuffle this. You can just chain the calls, okay? But you can change the calls as if like the output of the first is the input of the second, which is the input of the third, okay? And it returns in a sequence, okay? So that's one. And then after you have the shuffled cards, you have to push each card to the deck. That's where sometimes functional programming has a little bit of overhead. Immutability has a lot of overhead. Like in Eclipse collections, we actually have mutable, immutable, and unmodifiable, okay? Because each time you're mutating an immutable collection, you have to create an entire big copy, okay? So you end up paying a little bit of price depending on your use case. Again, your mileage may vary. You have to test out your stuff. You have to performance tune it, okay? And now, lastly, when you want to deal a Scala card, this is the code. Where is the return statement? Well, apparently in Scala, you don't need it. The last statement is what you're returning, okay? And I can see some confused looks where you're like, what exactly is happening? I'll explain. So first thing is you're just initializing your hash set. And then after that, you say 1 to count, because those many cards you want to yield. Okay, and we tested this with like a negative count. It doesn't do anything. And this is called as a wonder bar. Okay, similar to how Kotlin has it, where it's implied. This is a wonder bar, where basically it will infer the type and say, okay, fine, this is what you're giving me. All right, I'll be happy with it. Scala does that for you. And then you're saying in this set, just go on adding, and this is the last statement, return the set. Okay, that's pretty much it. Now, let me run the test. All right, it works fine. Okay, I think we have 5 minutes remaining. I can take more questions. Before that, I do want to show Eclipse collections. My Twitter handle is Nikhil Nanivadekar. If you want to tweet at me, follow me, get to know about some of my travel or hiking stories, dosa stories, idli stories. Yeah, I do publish them. And then the github.com/eclipse/eclipse-collections. That's the code repo for Eclipse collections. And lastly, I'm hiring in Goldman Sachs. So if you're interested, we are based out of Bangalore itself here, or Bengaluru. Feel free to reach out to me. My email is nikhil.nanivadekar@gs.com. I'll be happy to answer questions if you want to send me your resume, or have a if you're going to send me a resume, at least do me a favor, speak to me beforehand so that I can relate to the person whose resume I'm looking at. But I'll be interested in having talented people on board. I'm hiring heavily out here. Okay. So with that, any questions in the last 5 minutes? All right, no questions. I did an amazing job, or I did an absolutely bad job. I choose to believe the first. But thanks everybody for coming for my talk today. This is my 3rd year at GIDS. I was not planning to attend GIDS this year, but I guess when I'm supposed to be here, I am here. So thanks a lot for your support, and I'll see you in the hallway. I'm presenting again at 5:40 how to upgrade to Java 12. Lovely to have you. Thanks a lot. Have a good day. Bye-bye.